Oye, Ñelora. In this lesson, which is designed to be the STK focus for our ISAT Round 2 B series, which is focusing on the basics of budgeting. Basically, in this series, I'm going to have us focus on pulling access reports and getting all of our information by looking at the access reports, which is one of the most common reports that we actually pull and work with in our scenarios. The next series, C series, is actually going to be focused around pulling lighting times and looking at powering the satellite. This is probably going to be a shorter STK lesson video. There are a few things that are on the agenda, but we're going to assume that you've seen most of the previous lessons that we have seen in other series, especially the Round 1 series. We have several of those, and so some of the skills are going to build on that. I'm going to go ahead and add a brief look towards the end of bringing up the lighting times report, because I know that it's going to be a little bit longer until I'm able to complete the video lessons and scenarios for that matter in the C series, and I want to make certain that you've got a way that shows you how to access that here in an available lesson. All right, so of the things that we want to take a look at, the main one that I've got right now for the ISAT B series, ignore that page, that's for another lesson that I'm going to be shooting here shortly and will hopefully be linked on this page. Right now in this video, we can see a bunch of things are marked coming soon. Hey, this one's going to go right there. And then, soon enough, I will also be filming the Sheets lesson. I'm probably going to put a link to additional videos that expand on this and take a deeper dive on how to go recommendations on how to solve scenarios like this one, 2B1 Eyes on Earth. Now, usually I try and have 2 scenarios in a series before I actually do the lessons on them, so I can give you pointers on both of those. However, I know that I'm going to be going through and building those when I can, but I wanted to get this video out, and I planned out mostly what I'm going to be doing in the others. So between this and the Sheets video, I will still be able to give you decent pointers on how we want to approach these, even though those series don't quite exist yet. In this case, we're going to take a closer look at the Eyes on Earth scenario, which is ISAT 2B1. When you click on this link here, the briefing in PDF, it'll take you over to a series of files that you can download. Now, starting in our Round 2 series, we're going to start seeing that not only do you have the VDF and the mission brief, but you're also going to start seeing that we have additional files that are available in there. And part of this video is going to show you how I generate those and give us a little bit of context on why we generate those with this specific lesson or scenarios like it. Okay, so jumping over to STK. I've downloaded the VDF for this mission, and I've also got the mission brief as well. The mission brief is here. As we can see, the number of pages is starting to go up because we have more information in a given scenario. That's something that is noticeably different about our Round 2 compared to many of our Round 1 scenarios. Now, Round 1 scenarios, when you're actually competing, might have packets that are maybe about 6 to 10 pages, whereas as we start going into Round 2 and Round 3, you're going to start ending up with more and more pages. If for no other reason, then, we need to have information about the different components that you actually select. So in this case, we're looking at setting up a satellite in orbit of Mars and pointed towards, we can see it in the distance there, let me make this big screen, towards Earth off in the distance. Now our goal is, with this satellite, to collect data from Earth, data that we're going to keep track of in minutes. Now the idea on this is there's television programming and all sorts of cool entertainment stuff back on Earth, and we're going to download several minutes worth of information on that. We are going to choose from different scanners where the more powerful scanners will get us more data, more information for each minute that we download, but our end goal is to collect minutes worth of data from Earth. There are a couple reasons that this is the main focus of the scenario, and not the least of which is it's a good representation for the sorts of things that you would get in real life. Of the things that we're choosing are a scanner, which is going to collect minutes, but also possibly get extra data along with each of the individual minutes. And then we need to store that data onto a hard drive, or data recorder is the more technical term on this, though I like using the more common term as something that you might recognize. But a place where we store that information on the satellite, and then eventually, when the satellite can, it will send that information back down to a ground site, which we have here on top of Olympus Mons on Mars, one of the tallest mountains in the solar system, at least that we know of. Now, one of the things that I will bring up on this in STK, this is one of my few scenarios where the satellite, the propagator that I've selected for it is actually the two-body propagator. And I've gone back to that so that I can get a nice simple orbit around Mars that is not necessarily disrupted. It allows me to make certain that I've got a very periodic nature to this scenario, and that's something that I wanted for the very first scenario that we're actually taking a look at here, and it will tie into some of our methods for solving it. In most of the others, I'd do a J2 perturbation, which takes into effect the effects of some other gravitational bodies, including the moons of Mars in this case. And when I tried incorporating that, my orbit became a little bit more, we'll say, chaotic. It was still orderly, but it wasn't nice and regimented the way that I really wanted for this, the first scenario that we're going to deal with periodic trends, in other words, timing trends, in a scenario. Okay. The big things that we need are this. I'm going to leave it to you to actually read the mission briefing, but we're looking at a scanner that is going to generate data that we collect from Earth, and it has different qualities. The low quality scanner is lightweight, inexpensive, gives us very little data per minute, but also doesn't have any bonus factor along with it. Basically, it's low resolution imaging is what this particular scanner is actually providing. It's still useful, but it's not as nice as it could be for any given minute. If you go with the higher levels, though, they get heavier, more expensive, but they give much better data, more higher resolution, basically. So this is maybe setting the streaming service to your videos only set to 480, the old school kind of low resolution. Whereas this one might be a setting that is 4K. We get much better imaging on it. And as a result, there's a bonus factor for that higher value on it. Now, that being said, it also means for any individual minute, it's going to take up more space. We'd have to choose a hard drive to try and hold all of that data, but if the hard drive gets filled up, then we start losing data that the scanner actually collects. In this scenario, there isn't actually a penalty for that, but in future scenarios, don't be surprised if the people in charge are like, well, why are you collecting that data and not actually getting it back? You're just losing it. So we think that's a bad approach, and you might actually have a penalty for losing data, but not in this one. And then finally, we have the transmitter that starts emptying out the drive, but only when we're able to see the ground target where we're sending that data down. Now, in the other scenarios in this series, you may start seeing that you won't have it where the satellite can see the target, the source, Earth, the entire time. In fact, that's what the plan is for the next upcoming scenarios in this series, where you're going to have two periodic contacts. But that actually brings us to the main things that we need here in STK. Now that I've laid out our idea, the goal is we have information coming in from Earth that gets beamed over to our satellite. And the way that I've set this up, the satellite will be able to constantly receive information from the Earth. We're going to verify that in just a moment. Now, the satellite has to store all of that information until it can come around and see the ground site, OGRE, as I'm calling it, the Olympus ground receiver on top of Olympus Mons. And then whenever it can see it, the satellite that is, it will try and download as much of that information to the surface of Mars until it runs out of contact. So the key to this is all of the contact times. We're going to talk about different methods of solving this, but for the best methods, you're actually going to need to get more information about what our contact times are. Now, the first one is going to be, let's look at the information coming into the satellite. That's step one. So let's see how much we're getting. So I'm going to go to my satellite, right-click, and go to Access, and I want to see how much it accesses the target Earth, which is a planet. I'm going to click Compute, and then I'm going to click on the reports to bring up my access report. Well, in this case, I only have one line item. I've set up this orbit specifically so that the satellite in orbit around Mars, at least for the time period of our scenario, has permanent eyesight of Earth, eyes on Earth. In this case, for our entire scenario time, beginning 14 October 2350 at 0100 UTCG, and ending at a stop time of 28 October, same year, and about the same time, basically, we have a total duration of 20,160 minutes, which is the time between October 14th and October 28th at the same time of day. So we've got this many minutes of contact. Now, that's one where we have this completely uninterrupted, so every minute that the scenario goes through, your satellite will be able to make one more minute's worth of data that it will add to its hard drive. So our limiting factor is going to be this, because odds are good, we're not going to have a hard drive that can store all of the things on it. But this is one of the first reports that we would need to pull. And I've got all the information that I technically need from it, but to prepare us for future scenarios and for anyone who does not have STK access, I've actually pulled this report and created it as what's called a CSV. In fact, right here, we've got satellite MCRN to planet Earth access CSV. I'm going to try opening this real quick. Let's see if it will actually open it. We can see here, we've actually got where it says the access time. It tells me when it starts and stops, and that I have a total duration of 20,160 minutes. It's super tiny. I'd make it bigger, but it's just going to make my screen get a little distorted. In short, I've got it set up where you have this report available. And how did I do that? Well, up here at the top, I've got the save function, that's save as text, but the next one over has a little picture of the Excel icon. This is save as.csv. You click on this, and then you give it, I usually just leave the default name, but you might want to search around and get it saved in an appropriate folder. You can always go to the desktop, for instance, and hopefully you've got a folder that you can keep track of to work on this, ISAT 2B1, and I could click here, but you can see I've actually already created all of these reports, and I don't want to overwrite them. But I would just click save, and it would put that report right here where I could access it and do work on it. As you'll see in the Sheets video, I'm going to show you how to bring these reports into Sheets so that you can work with them. Now, that being said, this report isn't actually that useful after I get the key information that, oh, the satellite can see Earth the entire time. So I'm going to close this report. I'm also going to minimize this so that I can go back. And one thing that I want to point out here is we see a nice rhythmic track on the ground for Earth. If you change this to a J2 perturbation, you're going to see that these orbits actually spread out a little bit, and I no longer have 100% contact time with Earth. So I'm keeping this one simple so that we get a nice, easy to work with orbit. We can see here that now that I've pulled the access times, there's a line coming from the satellite out to Earth so I can actually see Earth. I can press play. I'm going to speed this up a little bit. We can see it going around Mars, but I have that line the entire time. The satellite is able to see Earth the entire time. So for every minute, we're generating data that is going on to the hard drive. Now, how much data? That comes down to your individual choices. So if you choose the low-level scanner, then you will generate 40 megabytes for every minute that you scan. If you choose the high-quality one, then you'll generate 110 megabytes. And you'll have to look at the capacity of the drive in order to balance those out. Quick note on this for this scenario, and this isn't uncommon, to make things simpler, we are simply telling you that 1,000 megabytes is equal to 1 gigabyte. Yes, we're aware that it's not exactly 1,000, it's actually a multiple of 2, and so that's not quite right, but to simplify calculations, we're going to use that for this scenario. So make certain that you're using the right conversion, even though it's technically the wrong conversion. Okay, back to our STK lesson, but I wanted to give some context because this lesson is designed to work in conjunction specifically with the scenarios that are tied to it. Okay, now we have our information on the retrieving data side, and then we could also then compare it to the idea of how much storage space we need on the satellite. What we really need to know is how often we actually have the satellite able to remove information. Well, it removes information by getting contact with OGRE. So I'm going to go back over to my satellite access, so I could right-click and go to access, but this time I don't want Earth. I want to know when it contacts OGRE. I'm going to click compute, and I'm going to bring up the report. Now this one is much more complex and interesting. We have a start time and a stop time. Because, as we watch, now that I've pulled the contact times between the satellite and OGRE, I'm going to rewind my scenario. We can see that we're talking to Earth, but I'm going to press play. When we go around, we are not talking to OGRE, and then bam, we're talking to OGRE. Whenever you see the line connecting the satellite and the ground station, just like that, we are talking. And whenever that's happening, your transmitter that you select, that's the last of your selections in this scenario, has a rate of how quickly it offloads information. Now I'm going to bring this up, and I probably will do this with most of my scenarios. I did have it set up where the lowest transmitter rate will offload information faster than the highest scanner will add information. That can be important, but it basically means if you're scanning and adding to the hard drive at the same time that you're transmitting faster than you're adding to it so that you know that you're not losing any data in between. It's a small thing, but I wanted to bring it up while we're actually talking here. But the important thing is this. I have my report, and I can see the first contact time with OGRE happens at about 3:11 UTC and ends at about 3:55. We can see that the duration, my satellite is talking to the ground site for about 44 minutes. This is all really useful information because if I choose the basic transmitter, it downloads, or transmits, I should say, so uploading, 150 megabytes per minute. So if I'm looking at this, I have 44 minutes. I could take 44 times 150, and that would give me how many megabytes I can offload from my satellite in this first contact. And that tells me how much data I've actually sent down to the ground and secured, which is the key focus for this mission. So I really need these numbers, 44.283, 44.2. Well, notice a bunch of them are 44, but not all of them. One of these goes down to about 38, and then the next one is about 10, and then the next one is 36, and then it goes back to about 44, 44, 44. That's one of the things that we're going to talk about in our solving video, and I'm going to draw your attention to right now. We have patterns that are showing up. Now, most of the data looks pretty clockwork, but we have small blips on it. We've got what appear to be 4 cycles of right at about 44 minutes, and then we end up with 37, then 10, then 36, then back up to 44. Now, what's causing that? That's happening because of the orbits. But I'm getting ahead of myself. I can scroll down to the bottom and I can get some very useful information. The smallest contact time, that's my min duration, was 9.77 minutes. And my maximum duration, the longest time, was 44.283. The average was 37.245. We're going to see in some of the recommended solving videos that you can use the average to kind of represent, hey, what on a regular orbit, about how much time of contact do we have, and we would have that. We've also got the total duration, which is this, and while you might be tempted to say, hey, we get all of those minutes, that's an assumption, and we may find that that's not actually a good assumption. But this can be a very good, in fact, very, very important report to be able to pull into a spreadsheet to work with. In fact, if I only had one of the reports that we need for this scenario, I would make it this report. And you'll see in the accompanying video on sheets why I think that's the case, because we can get so much information out of it. One of the things that I will say on this is we can also export this as the CSV. So this is the one that I really, really want. And so I can go to my desktop, I can go to ISAT2B, and then I can export it here. But once again, I've already actually got it, MCRN to facility OGRE access. So I'm not going to save over it because I'd rather use the file that I've already generated just in case I've messed something up. Okay, so this is another good one. I'm also going to bring up, whenever I asked for the axes, if you look down here, we've actually got our timeline filled in. Now, from satellite MCRN to planet Earth, we can see that there's just a solid orange bar. That's because I have complete access all of the time. But in this, I can see not only what I see in the report with 44, 44, 44, 37, and 10. Well, if I look down here, I have to look kind of close, but I've got kind of a thick bar, thick, 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 and then all of a sudden it goes very thin. It's almost just straight blue. Well, this is a thinner bar. That probably corresponds to the 10-minute. In fact, let's see, contact 1, 2, 3, 4, and then the 5th one is super thin. 1, 2, 3, 4, and then the 5th one is super thin. In fact, looking at the timeline down here that many students ignore can actually be very informative because it's going to take us where we need to go next. There's definitely clockwork, there's periods, there's trends, patterns that are happening here. And patterns, as they say, are holes in the armor. Patterns are how you can take something very complex and approach it in a reasonable way. Down here on the timeline, we get to see something that I'm very concerned about as well. I can see every time that I come in contact with the ground station, I'm in contact with it for about 44 minutes. But that doesn't tell me how long is in between the contacts. Well, if I export this as a CSV, in the Sheets video, I'll show you how we can actually use the information in this report to actually find out how much time passes between contact number 1 and contact number 2. But that's not what we're going to take a look at here in STK, at least with this one, because STK already has that programmed in. Which brings us to the last of the reports that I want to show you, which is going to be, I'm going to right-click and go to MCRN, the satellite. I'm going to go up to Access, which is right down here. And instead of clicking the regular reports, one other thing that I'm going to bring up, I can also bring up the Access graph right here. And I can see this is a bigger view of the timeline down below. I see 1 contact, 2, 3, 4, and then the 5th one is a super thin one. And then look at that. There's a big gap. A gap between this weird 10-minute contact and then the next contact after it. And that's actually one of the keys that we want to see. Now, being able to visualize this is great. I can see that I have what appear to be 4 regular cycles, and then a really small one, and then a large gap, and then I come back and I end up with, looks like 5 or 6 cycles. Although this is probably one of those other thin ones. We had like 30 some odd minutes, 10 minutes, 37 minutes, and then they went back to 44 minutes like clockwork until we had another one that was significantly smaller. We can see the pattern here in the graph. So don't be afraid to bring up the graph right over here, Graphs Access, right next to the report. But the last one that I want to bring up is this. I want more than just a graph. I want to be able to work with those numbers so I can see exactly how long is transpiring between my contacts, because then I know how much more information has been added to the hard drive in the meantime. And for that, we want to go over to Report and Graph Manager. Now, I've already set this up and saved it for you, so in mine, you're actually going to find it under My Favorites. But if you don't see it there, say you're trying to find this on your own, there's an option that says Installed Styles. Expand this. Now, this is only under the Access portion of the Reports and Graph Manager. So if you go to Reports and Graph Manager by itself, you may not be able to find this. But under the Installed Styles of Access, we can scroll down, and I'm looking for the Gaps report. This is actually the opposite of the report that we just looked at. The last report told you when we were in contact and how long we were in contact. This actually tells you how long we're not in contact. And so at the beginning of the scenario, starting at 0100 hours on October 14th, our first contact with MCRN to OGRE happens at about 3:11. As we saw earlier, that's when our first contact begins. Well, that's when our first gap ends. The first gap was 131 minutes, so I know before I can start transmitting back down to the surface of Mars, I collect 131 minutes worth of data, and hopefully I have all of that on my hard drive. If I don't, then that means that I got too small of a hard drive and I've already maxed it out. Well, that's one of the things that allows me to choose what I want for this scenario. I can see that at the very beginning, I'll have 131 minutes that got added to the hard drive, and then in my next dark period, is how I like to refer to it, it's between the areas that we can actually offload stuff, that lasted for 139 minutes, then 138, then 136, then 161, and then all of a sudden, here's one of the key things I want you to understand. Look at this. We go from probably about 140 up to 360. That's a huge jump. And then after that, it goes back to about 140. That's this gap that we're seeing in there. But why is it there? Okay, so first off, I can scroll down to the bottom and get the same things that we saw before. The minimum duration. The smallest period that I have is 61.8 minutes, but that's actually at the very end of the scenario, and that one's an outlier. It's only so short because my scenario ends and makes it short. So that one's not actually terribly useful for me. My max duration is useful for me because that's going to be the worst case scenario. The largest amount, I should say, of data that's added to my hard drive. So that number is probably actually a pretty useful one. Although having just the maximum isn't necessarily great if there's only one time that you have the maximum. What I'm looking for are the trends. And so for every 5 or 6 gaps, we end up with 358, 358, 358. So I'm going down and checking a few of these, and it looks like not only is my maximum around 358, but I'm consistently getting dark periods of 358 minutes, which tells me, hint, hint, that I might want to get a hard drive big enough to hold 358 minutes worth of data. Now, how much is that? Well, again, that depends on your scanner, because your scanner determines how much data you have for a minute that you receive. Now, that's one of the things that we can use this report to give us insight to start making a better design for our scenario. And that max duration is very useful. The mean duration certainly isn't bad either, but remember the mean is the average of all of these. So you've got a bunch of these that are 140, and then all of a sudden you have a 360, and that's going to pull your average, your mean, up noticeably. So we can see that the mean is about 171, but in reality, most of my regular contacts, the dark periods, are about 140 minutes. That gives me something else that I can use to start solving my problem. This is building to something that I like to call the U method. And we're reaching the end of this particular lesson in STK because I just wanted to show you how we can get these resources that we can use. Oh, I also provide you this report. And how did I do it? I go up to the export as CSV right here, and I exported it just the same as the others. So you have access, even if you don't have STK, to all three of these reports, so you can actually go through and use them to make an informed decision and try and find the best solution to eyes on Earth. I'm going to go ahead and close this one. There's one last thing that I wanted to show you in this, and it's not pertinent to this scenario, but like I said, it's going to be a little bit until I get to the next series. I want to show you how you can bring up the report on lighting times to see when your satellite is in daylight versus not. And now, while my satellite can always see Earth, it can't always see the sun. So I'm going to right-click on my satellite, and I'm going to go down to the Reports and Graph Manager. I'm going to click on that, and I'm going to go to, well, My Styles. For whatever reason, Range is the only one that's under there. And if I had pulled this report and then saved the file, you would find under My Styles or My Favorites a report that ends up summarizing some of these. But since we don't have that preloaded, I'm going to go with Installed Styles. Now there's a whole bunch of reports to pull from, but the main one that you're looking for, if you're looking to get when your satellite is in daylight, is in sunlight, right here, most of the way down, remember lighting times. Now you can pull up the graph, which is this one here. In fact, I'll go ahead and do that. Here's the graph. Assuming STK doesn't crash. I really hope it doesn't. Please note, it says the little stop sign here, it's thinking. I'm really worried that STK is going to crash and I'm going to have to, hey, yay, and then I'd have to reload it. Okay, I'm looking at the graph here, and we got all sorts of stuff. It's really hard for my eye to pick out the important information from this. So sometimes graphs can be useful, but sometimes not. What I really need is the lighting times. And I'm going to go over to Lighting Times Report. And I'm going to double click on that, or I could click Generate. You'll see that this doesn't take near as much processing power, but look at our lighting times. Dear me, we've got a bunch of them. Oh, the lighting report is also split up into 3 parts. By default, we've got the first set, which is sunlight. These are the times that your satellite is in direct, unobstructed sunlight. And we can see from the beginning of the scenario, we've got a cycle of about 28 minutes there, but that's because it's bunched up against the beginning of the scenario. And then I have sunlight time of about 67 minutes, then 57, then 67, then 57, then 67. And we can see once again there's a pattern to the numbers that we're seeing. But on average, we're spending either 57 or 67 minutes in daylight. Well, that will be great if you're trying to select how many solar panels you need to keep your satellite in power. Remember, solar panels will only generate power when they're in sunlight. So, on this orbit, I spend 67.6 minutes in sunlight. I could use that with my chosen solar panels to predict how much energy and charge I can build up to recharge my battery. In fact, this is just a slightly modified form of what we're doing with the current access times. We're just pulling a different report. And the lighting times are usually a little more systematic, more predictable than the access times for a couple of reasons, but not always. I scroll down, we see 67, 57, pretty much nonstop. We also have our minimum duration, the 28, that was at the beginning of the scenario, and the maximum duration, which is 67, but we had a bunch of them that were 67, and our mean duration is about 62. So once again, I could use those numbers to make a good estimate. Now, those are the sunlight times. I'm going to go ahead and mention it as the last part of our video lesson here, which is a preview of things to come. But penumbra times. Penumbra is the fancy term for basically the satellite's starting to go into the shadow of the planet is the way of thinking about it, and it's a lot like sunset or sunrise. In short, from the satellite's viewpoint, the sun isn't just a spot, it's actually a small circle. And now we're in penumbra when part of the planet is blocking a little bit of that circle, but not all of it. So we're in partial sunlight. Now, you might get an approximation that says if you're in partial sunlight, maybe you get half power from the solar panels. In most of our scenarios, to make it simple, we'll simply say you don't get any charging during penumbra. You only get charging during sunlight. Now, the penumbra are really, really short because it doesn't take long for Mars to end up blocking the sun for our satellite because it's moving very quickly. If I keep scrolling down, I can see the other thing that I need, the gaps report, if you will, for the sun. We call that umbra times. Umbra basically means shadow. And so this is when you are completely in shadow and you can't see the sun at all. Well, we have the timestamps of when that happens, but we also, most importantly, get the durations. We can see every time my satellite goes behind Mars, it ends up in darkness for 38.336 minutes, pretty much like clockwork. And so we've got a nice predictable number for how long we are going to be running our satellite without getting any power coming in. Now, just like the other reports, we can also take this. This is not in the folder because it is not needed for my scenario that we're talking about here, but I can export this as a CSV by clicking right here. Okay, those were the key things that I wanted to get across and expanding on them for things to come and hopefully some challenges that you might be seeing in the near future. So, hopefully that was useful. Until next time.